Hello to everyone. Topic of my report: features of structures and calculation of steel spiral fault silos. There are many industries which are related with the processing of raw materials. They are constantly developing their technologies. This requires the sustainable development of the construction industry. One of the most necessary stages in the technological process is material storage. The requirements of the modern store for bulk materials are economy, environmental friendliness, larger capacity, rational operation. Metal capacitive structures for storage of various types of bulk materials are one of the most common types of building structures. The dimensions of the silos, their shape, methods of support on the foundation, as well as the location in the plan, are assigned in accordance with the requirements of the technological process. Depending on the type of wall, there are the following types of metal silos: welded silo, panel silo, spiral fault silo. One of the most advanced types of thin-walled spatial construction are highly industrial and economical metal silo of the spiral fault type. The construction of spiral fault silo was developed in 1968 by a German scientist, Xavier Lipp, who used the special equipment for processing of sheet metal and used it for the construction of spiral fault silos. The first silo was built in 1969 in Germany. Since the late 60s in Europe began using the silos with this type of construction. Within 10 years of study and research, in practice, this technology has proved successfully, and since the early 70s, large-scale production of steel spiral fault silos has begun. The construction of the spiral fault cylindrical silо is formed with the help of special equipment which connected a metal strip in a spiral and formation of the folding lock at the same time. The folding lock is located outside the silo wall at a slight angle to the horizontal plane and forms annual ribs. Spiral fault silo shell design is significantly different from traditional corrugate metal prefabricated silo with bolted joints. The specifics of the design of the spiral fault silage, which affects to their stress-strain state, is the ribs are placed in a spiral but at a slight angle of inclination. Those folding ribs work in a complex stress state. They increase the rigidity of the silo shell structure in tension and bending in the annual direction. Quite frequent placement of the ribs and the small angle of their inclination allows us to consider it as a system of closely placed horizontal ribs and the stress state of the field silo as axisymmetric. The main normative document of Ukraine that regulates the design of metal structures, including thin-walled shell, is DBN. This document contains general recommendations for assessing the strength and stability of torus shells. The main loads and effects on the silos are horizontal and vertical loads from the pressure of built materials, overweight of a construction, loads from snow on a covering, horizontal pressure due at temperature differential, loads from heat cables, load from wind pressure. These loads are temporary except for its own weight. The calculation scheme in the case of a field silo can be solved in a simpler or in a more precise formulation. Simplified calculation scheme, in a sense of entering the source information for the computer, is reduced to the calculation of a whole shell under the assumption that the shell height have one thickness. The calculated horizontal loads and total vertical pressure are constant and equal to their maximum value. A more precise calculation scheme is reduced to the calculation of the entire silage as a cylindrical shell with frequent discrete placement of annual ribs. The calculation is performed on the action of horizontal and vertical loads. In each short shells, these loads are assumed to be constant and equal. The calculation scheme of the whole silo is accepted as a component system of short shells connected by horizontal folding ribs. All formulas for determining the loads of the structure were given in the article. In the end, the whole calculation is reduced to checking the overall strength of the wall, which is in a momentless stress state. The strongest stress of a shell, depending on wall thickness, is checking to durability. Concluding what has been said above, I want to stress that there are several unresolved questions left. Lack of research of the stress-strain state of these shells because this structure have a folding lock. There are also no developments regarding the reliability of this silo, though the basic principles of calculation of reliability of metal construction are developed. As a summary, I would like to say that the task of this report was to review the design features and analysis of the method of calculation of metal spiral fold silos in relation of the current standard. Based on the above material, the authors are planning to conduct an experiment on a full-scale silos to compare theoretical calculation with the experimental results. Thank you for your attention.